In this video, we're going to talk about the reduce function and how it's an abstraction of a very general recursion pattern. It's a lot more useful than you might think. Now, you might not realize this starting out, but functional programming is all about transforming data. You take some input in, perform some transformations on it, and then spit the output back out. Now, there are a lot of different ways you can transform data. Some of them are very simple. Things like modifying the value of a collection or changing the structure of a hash map aren't usually too difficult to pull off. But others are a little bit more complicated. Maybe you want to take a collection and combine all the values somehow, or take those values and build them up into an even more complex collection. Doing this with recursion might seem a little bit complicated at first, but there's actually a pattern to this that's used in a lot of these situations. Just add a parameter to your function and use that to either collect or build up your values. For instance, we can add all of the values of a collection together using an accumulator to keep a running total. Or we can build up a collection by adding stuff to an accumulator as we go along. For instance, here we have a collection with numbers, and we use our accumulator to store its squares and its cubes in a nice literate format. Now, not everybody loves writing these recursive calls, and if this is such a common pattern, is there any way to factor it out? Well, it turns out there is. This is exactly what the reduce function does. Here's how you'd add up the numbers in a collection using reduce. And here's how you'd build up an array of squares and cubes. Reduce is in just about every modern programming language, and while it's really the granddaddy of these types of functions, you probably end up using things like map more often. Still, it's nice to know how this sort of thing works and how to approach these problems for when you run into them. Now, if you've watched through this video series so far, you're probably wondering, well, when should you go out and actually start trying to write functional programs on your own if you haven't started already? And honestly, this is, I think, the point that you should actually go out and try and figure out how to do this in the real world. At this point, you should know how to handle manipulating variables, collections. You should be able to emulate loops using recursion, and you can even do some more fancy collection and data structure processing using things like reduce, as we just talked about. So go ahead and go out there and see what you can do.